Almost every modern physics textbook contains a fundamental geometric error regarding spinors, the mathematical objects used to describe electrons and other spin 1/2 particles. Textbooks explain the 720-degree rotation using the belt trick, visualized as 2 loops with a 180-degree twist. But a 360-degree loop plus a 180-degree twist equals 540 degrees. Multiplied by 2 loops, that's 1080 degrees. The standard analogy is off by exactly 360 degrees. While the math physicists use is correct, the geometric reality we map onto it is not. Fixing this specific error reveals a hidden structure that connects the mass of matter to the deepest problems in number theory. Eugene Wigner famously called this the unreasonable effectiveness of mathematics. It is the observation that abstract equations often predict physical reality long before we have the tools to see it, a pattern most famously demonstrated by Paul Dirac. In 1928, Dirac's attempt to write a relativistic equation for the electron produced 2 solutions. He assumed the second was a mathematical artifact, but it was a literal prediction of antimatter, discovered in a cloud chamber 4 years later. James Clerk Maxwell experienced the same phenomenon. He added a correction term to his equations purely to fix a mathematical asymmetry. That correction unintentionally proved that light itself is an electromagnetic wave. Albert Einstein's general relativity, which describes gravity as the curvature of spacetime, relied on complex geometry developed over half a century before he needed it. Bernhard Riemann had invented the geometry of curved spaces in 1854 as a purely academic exercise, unaware he was providing the blueprint for the universe. In these cases, the mathematics was not a map of reality, but a generator of true statements about it. If we follow the corrected geometry of the spinor, it tells a story that reaches far beyond the electron. The 720-degree spinor is not a tangled belt. It actually requires a very specific, continuous geometry to close, the T1 Mobius parallelogram toroid. This path is one continuous loop with one 360-degree twist, treating both as the same geometric event. A single force, delta, drives both advances simultaneously. The outer trace accumulates 360 degrees, while the inner Mobius face adds another 360, closing exactly at 720 degrees. By treating the path as an undivided continuous motion, we finally see the invariant features that are hidden when the path is cut in half. The toroid's outer circumference and inner Mobius face possess different radii, so a single momentum step covers different angular distances, exactly 30 degrees on the outer face and 24 degrees on the inner. This creates a constant beat residual of 6 degrees, or pi over 30. This 6-degree beat is a topological invariant. It does not change with particle speed or energy. It is an inherent property of the geometry itself. If we divide a full 360-degree rotation by this 6-degree beat, we are left with exactly 30 discrete positions. This is the mod 30 coprime lattice. It is the fundamental coordinate system of the geometric baryon physics framework. When we map particles perfectly onto the intersections of this geometry, their masses are no longer arbitrary. They are forced by the winding conditions of the lattice. This method predicts the masses of 55 hadrons and pentaquarks with an average error of less than 0.25%, using 0 free parameters. The mass of matter is not a random value we measure. It is a direct consequence of the 6-degree geometry of the spinor. This bridge between geometry and matter extends deeply into pure number theory, specifically to constants that have long defied explanation. Catalan's constant, G, is an irrational number that has resisted closed-form evaluation for 150 years. Traditional analysis treats it as a single alternating series, missing the 2-lane structure that creates it. On the mod 30 lattice, Catalan's constant is the value of a Mach theta Euler product. The alternating signs represent the forward and return legs of a physical chirality loop. G is the numerical witness of this 2-lane balance. It is a mod 15 arithmetic object living inside a mod 30 geometric container. This same balance provides a physical context for the Riemann hypothesis, the conjecture that all non-trivial zeros of the zeta function lie on a critical line, where the real part is exactly 1/2. The Riemann zeta function can be viewed as a superposition of prime waves. On a 2-sheeted Mobius toroid, these waves traverse the outgoing and returning faces. For a stable particle, the system must meet a resonance condition, where the outgoing wave's amplitude equals the returning waves. If we represent the outgoing amplitude as p to the negative sigma and the returning as p to the negative 1 minus sigma, they only balance when sigma equals 1/2. The critical line of the Riemann hypothesis is the geometric midpoint between the two sheets of the spinner's double cover. The zeros are where these waves cancel, nodes in the geometry of the winding field. This suggests that space is not a global stage, but a local relationship. The three spatial dimensions we experience are the three toroid tiers, T1, T2, and T3, that each particle carries internally. Prime numbers provide the conditions for a mathematical circle to close. Particles provide the conditions for a physical winding to close. When we look at number theory and particle physics, we are looking at the same geometric constraints. One is a story of circles, the other is a story of matter. In the corrected geometry of the spinner, they are the same story.